record my answer to this. So we had an assignment 3. In the first question, I've asked you to build a system dynamics model, SIR type action transmission model.
Yeah. And then in the second,
the
second part of that, we are to create like a similar model in agent-based system.
Yeah.
And it says that we need to make sure that the rate of like infection spreading is identical to what it was in the system dynamics model. And I don't quite understand like a mathematical method of
Okay. Let me go look at the exact wording I specified there, because that isn't lining up with my exact recollection of what I had said here. So assignment 3. Here we go. Okay. This is.
page 2.
Oh, what's that doing there? Okay. Page 2 here. Yeah. Sorry. Page 2. These 3 eyes. Okay. Okay. Right. So yeah, this is a far more circumscribed thing. So I said each such contact received by a susceptible should confer a chance of infection equal to that assumed in the system dynamics model above. So what I'm saying there is, if someone's been exposed, if a susceptible has been exposed to an infective, the chance that that contact has actually infected them, the chance that they've actually been infected by that so-called discordant contact should be the same as in the system dynamics model. And in the system dynamics model, wait a minute, okay, right, yeah, here we go. There we go. It's beta. This is this chance per discordant contact, per contact produced susceptible and infective in the system dynamics model. So all I'm saying is use beta as the likelihood of infection here.
So using beta makes sense, but using like the context number is much more difficult, because in the system dynamics model we just say that they're going to have 10 contacts per given time. But in the agent-based model, it's based on the random connections of the agent.
Okay, but this is something, I don't know if you were here for my comments on this last time, and I don't remember if it was after class or before class, but you're putting your finger on something that's an important difference when thinking about the context. And I want to distinguish 2 factors that are oft easily confused within an agent-based model. So within this agent-based model, we have people in a network, right? And within this, excuse me, they're in a network of various sorts, right? A distance-based network. So I'm all confused because this is implementing collision. I don't know. I was out to lunch, I guess. Because this is not about this particular problem. It's not about that. In this case, I ask you to go through several different types of networks, right? And for each of those types of networks, a given person will have some number of connections, right? And what I'm asking you to do is, to separate conceptually, how many connections they have on the one hand, from how many contacts they have via those connections on the other. So a person might have 10 connections to other people, but they only have one contact per unit time through those connections. Alternatively, they may have one connection to another person, but have one contact per unit time, and it's always occurring, therefore, with respect to that person. With 10 connections, if they have one contact per unit time, it occurs with a random one of those connections. They might have one connection and 10 contacts per unit time, in which case it's like they're sitting next to someone, an office mate, and they're sneezing, very, very frequently. Alternatively, they may have 10 contacts per unit time and have 100 connections. It's like they're in the Place Real and they're sneezing up a storm in the same way. And so I'm asking you to separate those issues out. And what I'm asking you to normalize for, what I'm asking you to hold constant between the two models, the system dynamics model on the one hand and the agent-based model on the other, is the rate of contacts, how many contacts they have per unit time. In the agent-based model, you're going to have different numbers of, you're going to have connections, discrete connections associated with agents. The number of those connections is a different matter than the rate of contacts. Does that make sense?
Yeah, I think so. If we're transmitting a single infection,
yeah,
that means that we have to compute the rate. So you're going to have to transmit that single infection like X number of times per unit time. When you specify the rate in any logic, it's like per unit time. So if we want to transmit, like let's say we have 10 contacts, it's like you'll have to make the rate equal to C times beta.
No, because here, these are really good questions, but here, there's going to be a rate of contacts, the rate of exposures. Let's think of it as exposures. Contacts would be another word for it. So the rate of exposure events, things like sneezes or coughs, right? Okay, so there's a rate at which those are occurring, right? And that rate is going to be equal to C, as in the system dynamics model, something per unit time, so 10 sneezes per unit time or whatever. And each such event will lead to a message being sent to a particular randomly selected neighbor. Maybe they have one connection, one neighbor in that sense. I'm using this term neighbor, meaning a network neighbor. It's sent to a randomly selected neighbor, that one person, right? On the other hand, they may have 10, and it's one of those 10, right, that it's sent to. And then when that person receives it, they don't automatically get infected. They have a certain chance of getting infected. And there's actually two ways of handling that in any logic. Can anyone, let's crowdsource this. Can anyone tell me one way to handle that? Sorry? What's one way you could have, when a message comes in, you have a certain chance of something happening? You could have a dice roll. Okay, there's a dice roll conceptually, and how do we realize that in any logic? So here we have a state, and there's a transition out, and what goes there? Is it a smiley face? Well, what goes there? What goes here? It's not my face either. So what is it that goes there that would allow you to have a conditional thing happen? How would you, those from computer science background, speak as with one voice? In a flow chart, traditionally, or in a block diagram for those in some certain types of block diagrams in engineering, how do you indicate a conditional situation? You put in a what? Yeah, a diamond like that. Does that exist in any logic? Yes. So there's a diamond here that it's in the palette. It's in the palette, and you put a diamond. That's one good way to do it. So over here in the state chart area, you will go and you will find a branch, it's called. Mm-hmm. And there'll be one default path out of this, and one path that continues on. This might be the default path, this path, the path down to infection might occur with a certain chance. And you might want to use AnyLogic's random true function. There's a function called random true. I think you should have seen it in some of the videos. But you say random true. It's basically a Bernoulli draw. In other words, it's a coin flip with a weighted coin. You could say random true 0.8, and that will basically flip a coin, a weighted coin, where, Lincoln has a, big chin, big nose, and so it's more likely to be, it's more likely to be tails. I guess that would mean the Lincoln Memorial is really heavy or something. But in any case, it would land up with a with 80% chance. Heads up. So it would be true with 80% chance. And alternatively, it could be 0.1. It would be true with a 10% chance. So you might want to use that associated with this branch. So that would be one way to do it. Now I have to tell you, and this is just a tip. I find AnyLogic's branches a little bit ornery to deal with sometimes. Sometimes it gives this message about like too many default exits, and you got to remove one of the things that goes to it and put it back in, and then it all works. So just give it a bit of time and futz with it a little bit, and I think you'll be fine. That's one way to do it. What's another way to do it in AnyLogic? A guard. Excellent. Excellent. So one thing is this transition here, instead of having a transition and a branch, you could have what's called a guard. And the guard will determine, okay, this transition could go off. Is it really going to go off? And it will go off, if you want it to go off with a 10% chance, you do random true 0.1, right? Or you'd have a parameter whose value is 0.1, and like probability of transmission, given infection, given contact or whatever, given exposure, and you'd have random true of that parameter name, right? And so that guard, it would flip a coin and say, oh, it's true this time. The person's going to get infected. In that case, you don't even have the branch in the middle. It's just a guard in there. Now, I'm perfectly happy with both of these solutions to this problem. You could have the guard, or you could have this. Why might you, speaking from a perspective of software engineering, why might you prefer one to the other? So, do I secretly have a preference? You do it with a guard. Oh, sorry. I beg to differ. Sorry?
The branch is more extensible, but the guard is more concise.
Okay, the guard is more concise. It has the virtue of concision. The branch is more explicit. So you actually glance at it and you can see, okay, it's not always going to occur. It's going to occur with a certain chance. And so you could argue it's more transparent as to what's going on, that there's a certain chance that you'll get infected. In other words, it's not a given that you'll go here, and the guard might be overlooked. But the guard is more concise. It abstracts away from the vagaries of under what conditions it happens, and even that there are conditions. It just shows you a direct connection. I personally have a weak spot in my heart for the branch because it is transparent, and I think that it maybe brings out the fact that there's some logic there a little bit more clearly. But either of them has virtues to recommend it, and I will happily accept them. Yes, question.
So that all makes sense, but there's still like this confusion between the number of connections and the amount of contacts per unit time. And so I think this becomes a clear difference between the systems dynamics model and the AgentBased model, in that you are connected to, you are connected to all recovered people. Then your contacts per unit time, it doesn't matter, you can't infect anyone.
Right.
And in the
that's correct.
Model, it's not like that at all.
That is exactly correct. And this is one of the things I'm hoping to bring out, and in fact it bears directly on